Hey folks, it's Mr. Heier. We're going to talk about momentum and change in momentum today. As I said yesterday, this is our last unit before the final. So we will spend some time talking about this and then collisions. And please don't forget to look at your final exam review where you can replace some low grades with a hopefully better grade, particularly zeros. Be sure to look at the announcements for that. We'll talk more about that on Wednesday. All right, so momentum and change in momentum. All right, so momentum is defined as a couple of ways. We can think of it as inertia in motion, because inertia is mass if it's moving at velocity. So momentum is just the product of mass and velocity. The equation we use is P equals mv. Why momentum is P, I have no idea, but that is what is typically given. So that's what we use, right? And the units for it is kilogram meters per second for momentum. So just a couple of quick examples. What's the momentum of a 10,000 kilogram truck moving at 25 meters per second? So P equals mv. So that's going to be 10,000 times 25, or 250,000 kilogram meters per second. All right. The second one is the same. I'm not going to worry about that one. Momentum is 650 and your mass is 65. How fast are you going? So again, P equals mv. P is 650. Mass is 65 times v. We divide both sides by 65. We get velocity is 10 meters per second. All right, so what's really important here is how momentum changes, though, just like with energy. So the change of momentum, you must change the mass, or you have to change the velocity somehow or another. All right, so changing the mass, so change of velocity is defined as acceleration. So you can accelerate something, right? Which means that you have to apply a force, right? And then you can also, changing momentum by an object by altering velocity requires a force. And of course, you can also change the mass. Right? Change in velocity by applying a large force over a short period of time. That's one way to do it. Right? That would be kind of like when if you have a baseball hit at you and hit you in the head, the velocity is going to change over a very short time, so the force is going to be really, really large. Or we could use like an airbag. Or an airbag increases the amount of time things are in contact, and so it's a smaller force over a long period of time. All right, so here's an example. If you've ever been driving through the mountains, you'll see these I'm going to move my picture here. You can see these truck runaway ramps, where sometimes when their air brakes fail, you'll see these long ramps that are made of gravel, and they just run out, and it allows gravity a long period of time to slow the truck down. So you have a really long period of time, small force, and you're eventually able to stop the truck. If you're traveling through the mountains of Tennessee, you'll see them occasionally on the side of the road. All right, so change in momentum is also known as impulse. Okay, an impulse is a force exerted over a time period. So impulse can be written as force times time. Right? And so anytime you see change in momentum, that's the same thing as impulse, and that's the force times the time. And now we're going to do a couple of examples where we use that. Right, so example 1, a 1,000 kilogram car moves at a velocity of 60 meters a second. What's its momentum? We know that the momentum is just going to be 1,000 times 60, or 60,000 kilogram meters per second. Right, if it slows to 5 meters per second, it's going to have a new momentum, and that new momentum is going to be 1,000 times 5, or 5,000. So it dropped considerably. Right, so what's the change? Well, the change is just the final minus the initial. Right, so 5,000 minus 60,000, or negative 55,000 kilogram meters per second. Right, and that's the same thing as the impulse. So the impulse is also the change in momentum, negative 55,000. And we know that is equal to force times time. And so it says if that change occurred over a 3-second period, how much force is applied? So we say impulse is force times time. So 55,000 would be equal to force times 3. We divide both sides by 3. And we get a final force of 18,333 newtons. So that's a quick way that you can actually figure these things out without having to measure acceleration and everything else. All right, so second example, you throw a 57 kilogram tennis ball against a wall with a speed of 15 meters per second. What's the initial momentum? And again, as we're doing this, you need to pause it from time to time. Please do so. So 57 times 15. It bounces backwards now, so if it's going backwards, it now has a negative velocity, so velocity of negative 12. And so it's got a momentum of negative 684 kilogram meters per second. Because momentum is a vector, it has direction, it can have a negative sign, just means it's going backwards. So the change of momentum is just going to be the difference between these two. So the final minus initial, final minus initial. So that's going to be negative 684 minus 855, or 1,539 kilogram meters per second. And then if the ball exerts 2,000 newtons of force on the ball, how long are they in contact? Well, we know that impulse is force times time. The impulse we just calculated. So it's going to be 1,539 equals the force times time. The force we know is in the same direction as the other, so it's negative. So it ended up being 0.77 seconds. The ball didn't apply force for very long. All right, and then the last one we can do here, 300 Newton force is applied to a 150 kilogram box for 10 seconds. If the box is initially at rest, find the final speed of the box. So we're working on this a little bit backwards, right? We're given a force, we're given a mass, and we're given a time. All right, so we're gonna find out the impulse first. So the impulse is force times time, force times time, or it's going to be 300 times 10, or 3,000 kilogram meters per second, right? That's the same thing as my change in momentum, right? So my change in momentum, delta P, is equal to 3,000. Right? Well, and that's equal to my final momentum minus my initial momentum. My initial momentum is 0, so my final momentum is 3,000. That's equal to m times v. So 3,000 is equal to my mass, which we said was 150 times v. So my final velocity is 3,000 divided by 150, 20 meters per second. All right, practice these. You've got practice problems as well. And if you have questions, get on Zoom and we'll talk about it. And we're going to go through a couple of these problems tomorrow on Wednesday, as well as talking about the final exam review. All right, y'all have a great day.